And then at this point, let's make sure we do our last ones here. Are these two attracting or repelling? They are attracting. Okay, if you haven't already, draw these in correctly. Don't depend on me to do it. You got to figure it out. So we'll call these 2 centimeters again, and let's do this color. So there's 2 and there's 2. And let's go ahead and name these correctly. I can already see there being an assessment, me giving you a diagram and having you draw the forces correctly. I can already see that happening. So FE, this is 2, 3, and FE 3, 2. All right, so there are 3 charges and a whole set of forces here. Questions on this? If you do not have this, you cannot succeed. If you do not have this right now, you cannot move any further and expect to be successful. So make sure you can understand this part, because we're about to apply vector addition to figure out what. Where am I going with this? Can anybody be insightful and try to figure out where I'm going? Ben thinks he's got it. Where am I going with this?
They're going to go outwards.
They're going to go outwards. I think what he's trying to say is, if we were to keep these 2 stationary, how is this one going to react? Where is it going to go? This is
down to the left, to the right.
Down and to the right. They're saying it's going this way?
Yeah.
Okay, how about this one? If I kept these 2 stationary, where are these 2 going to go?
Up.
Where's this one going to go?
Up to the center in between them.
Up through the center between them. Okay, what if I kept these 2 stationary? Where is it going to go?
Out. It's going to go down to the left.
Down to the left. All right, so we're seeing this because of where the forces are. So now let's figure out the basic way of doing vector addition. And okay, I'm going to bump these up. And we're going to do vector addition in 2 dimensions here. And let's do this.
Can we draw a new graph?
I'm actually just going to zoom in on, Q2. So I'm going to do this. And we're zooming in on Q2, and Q2 is right here. And we know we've got forces acting on it. This is going to be here. 1, 2. I'm going to zoom in a little bit. So these are going to be 4. I'm going to double the length of them right now. Zoom by a factor of 2. So everything that was 1 centimeter now before is now 2. So those were 2 centimeters. Now they're 4. And I'm going to approximate this angle. It looks like it's about here. I'll move this down. Those skills. Okay. And we have 1, 2, 3, 4. And there we go. So I'm going to relabel these FE 2, 3 and FE 2, 1. Notice they both start with where it is. How are we going to determine exactly where it goes? Because all of you got it right. It's going to go down to the left. It's going to go down to the right. When the kid hits these people, they're going to go this way. You all have it, but this allows us to make it really, really precise. And with that understanding, we can really do a lot. So the first thing we got to do is we got to do vector addition. And you should be going up to your notes and say, bring the tail of vector A to the head of vector B. So I'm scrolling up in my notes here. I'm saying I need to add these vectors. So what I'm going to do here is I'm going to take this. And if I move it around in this way, am I changing the direction that it's going? No. If I turn it, I'm changing the direction. Yes. So I'm going to keep this exactly parallel, well, as exactly as I can get it. And I'm going to move it this way. And right now it starts here and it ends, actually starts in the middle, and it ends at 4. It's 4 centimeters. So I'm going to move this over to the head here. Kablam, like that. And here we are. And so we'll do step 1. So move vector A to vector B. This is for anything, but we're specifically doing these. And so now this is going to be, I'll put in parentheses, FE 2, 3. I'm putting in parentheses because we've moved it. Anybody want to be insightful, try to figure out my next step? What am I doing? Sophia?
If this is a triangle
Oh, everybody listen up really closely. Sophia, say it one more time, but let's project from that diaphragm.
If you draw a line straight down and make a triangle from Q to, that's the force of gravity.
Oh, not gravity. Let's assume that this is in the same plane as the table. So maybe there's gravity all going down into the table, but because that's in a different plane, different force, we don't care about it. And let's remember also that the static electricity force is different than gravity. Thank you for bringing it up. I didn't realize that we have some confusion. But you're really close. You're really close. What are we going to do here? I've got a couple hands in the air. If you're not thinking about it yet, think about it. Apply yourself. Use that noodle. What are we going to do here? I got a few more. Let's get a few more hands in the air if you think you know what I'm going to do next. Oh, all right. Now we're all getting it. Mr. Wanasilia, what are we going to do since this applies to you and your situation where you're hitting Dylan and Tavish? What are we going to do?
Well, you're going to use the two vectors to make a force triangle.
Ooh, I don't know what a force triangle is, but I think what you're saying is I should connect the starting point to where I have here. Is that what you're saying?
Yeah.
You're absolutely right. I don't know what a force triangle is. So,
Just made by looks.
okay, it looks like I see a triangle, and they're all about forces, so maybe that's what it is. So this here is going to be the resultant.
That's it, FE2.
This is the resultant force, and we're going to label this F, and I like to write, I'll just do R. But remember that the R, you have to remember what it means. It's the resultant force. It's the force that's resultant here. And I'm going to have a definition for you here.
Wait, what did you write? Oh, no.
Where is it? Resultant vector. The vector that results, or we'll say, what's one other way to say results? What can I use here? The vector that results, or we'll say represents
The finished product.
the, what do I have here in my notes? Results. Shoot, I'm messing this up. The definition I have here is the vector that results when multiple vectors are combined, but I don't want to use the word results in the definition of resultant vector. The vector that results or represents the combination of vectors. Or I'm going to say, what's going to happen? What's going to happen? That's kind of what we're doing here. The what's going to happen. So this is the kip's going to go here. It's going to go this direction. But I'm going to let you all get caught up, and then I want to have a quick thing, and I want to really emphasize what you're figuring out here. This is not trivial at all, in any way, shape, or form. What you're figuring out. And here's my specific question. You can think about this in your notes. What are the two things on the resultant vector that we can figure out? What are the two things?
Its length and its angle.
Oh my gosh, nailed it. Say it one more time. What? The what?
Its length and direction.
So what do we get out of its length?
How
force.
What does the length represent?
The force.
I'm looking for a particular word here.
the strength.
You're right. It is the force, the magnitude of the force. How hard Kip is pushing. What else can we figure out?
How long he's
In what exact direction? So this is just using, I don't even necessarily need to use numbers to figure this out. This is just drawing lines and making them straight. But I can figure out not only what direction, but with what quantity, what magnitude. So without using numbers, we're able to use vector addition to figure out these values. I can say, I knew that this was 4 centimeters. I knew that this was 4 centimeters. Using basic geometry and trigonometry, I can calculate the length of that. And then using my scale, I now know down to the decimal point what values I can get out of this. So this is not trivial. I can tell you, if Kip were to hit them, go in that direction, I can tell you not only the direction, but also the exact speed, the exact how quickly they're going to go. So now that right there is our vector addition, and I feel like this is a pretty good area for the notes here. How are you guys feeling? How long have I been talking? I've been talking for, oh my gosh, 30 minutes plus before I started. It's about 35 minutes. It's probably the maximum that I want to go to. But don't wrap up yet. I've got an activity for us to do, and it is the electric field hockey.